3.3, Conservation of Energy 2. The ball, mass equals 1 kilogram, is initially stationary, that means not moving, at a height of 4 meters. So we know that this height is 4 meters. What is the potential energy at the top? So we can use that equation. We're going to write delta again. That's the change in energy if we go up or down. Okay. So that's going to equal, the mass is 1. Gravity on Earth is about 10. Change in height is 4. Multiply them together and we get 40 joules. So that means at the top, this is 40 joules. At the top, it's not moving, so the kinetic energy is 0. So the total energy has to be 40. In the middle, so this is 40. This is 0. In the middle, potential energy is 25 joules. We know the total energy, if there's no friction, is the same everywhere. So this has to be 40 minus 25, which gives us 15. So this should be 15. For the last part, on the bottom, we say that PE is 0. The height is 0. 40 minus 0 is 40. So all of them is kinetic. Okay. So we have this table. Yeah. Next. So we have this energy. How fast will the ball roll at the bottom? At the bottom, energy is kinetic. Kinetic is 40 joules. We saw that right here. Kinetic is 40 joules. We know kinetic energy is 1/2 mv squared. The mass is, we're told, 1. We want to know the velocity. So 40 equals 1/2 times 1 times velocity squared. 40 equals 1 divided by 2 times 1 times velocity squared. Okay. Let's give ourselves a little bit more space. I go line spacing, I go remove space after paragraph. 1 divided by 2 times 1. There are a few ways of doing it. One way of doing this is just calculate it out, that's 0.5. And then you can divide both sides by 0.5. That's one way of doing it. So 40 divided by 0.5 is 80. 0.5 divided by 0.5 is 1, it goes away. Last step, we take the square root of both sides. So that means that v is the velocity. It's the square root. I can write sqrt for square root of 80. If we go to Google, square root of 80 is about 8.9. So this is about 8.9 meters per second. So that's how, if we know how high it started, we know using conservation of energy how fast it is going at the end.